When we're mapping interval and ratio data, we don't necessarily want to put a different symbol on the map for each numeric value because there can be those numeric values can vary a lot. So what we basically do is that we break these quantities down into variations or changes in number, and then for each of those changes of number we put a different size or color or thickness of line onto the map for each of those ranges. So in this example here for cities, it doesn't matter if the city has a population of 8,500 or 295,000. Both of those would fall within this range here. So every place on the map where there was a population anywhere between 8,200 and 300,000, this is the symbol that would appear on the map. The same with the yearly precipitation over here. 15 inches would get this color, as would 16 inches, as would 17 inches, as would 14 inches. And not until you get to 18 inches would the color change to here. So we break this down into categories, and we would call this a classed map because we've broken it down into categories or classes in order to apply these symbols to the map. So here's some examples here. This would be a classed map that's sometimes called a choropleth map. And this is just changing the colors based on these categories. So once again, we're not trying to apply every shade of yellow between these two. We're just saying that the value falls anywhere between 690 and 24,000. We're going to apply this yellow color to the map. And so these are examples of classed or categorized maps. And the same we can say with the size of these circles here. The size of that circle for the largest ones here represents a state capital population anywhere between 640,000 and 980,000 in this top example here. So we can see that we don't try to account for every single different size between these. We just use 4 different sizes and apply those to categories of numbers where each one has an upper and a lower boundary associated with it to make these classed maps. If we're applying colors to a choropleth map, it's a really good idea to use the same hue, but just change the saturation and the value as we move through the different categories. So in this example here, this looks like something like population density because we can see the area around Portland really stands out and the Willamette Valley, where some parts of eastern Oregon are have much lower population densities. So the higher the population, the darker and richer the red color becomes here. This is a much better way of going than just applying random or in this case rainbow colors to population density, because some people have a hard time remembering which order the rainbow is in, and this one is typically easier for people to interpret if we keep the hue the same and then we just change the saturation and the value. Of course, we don't have to classify our data. If we want to, we can change the symbol for every single point we put onto a map. And that's what's shown here. Once again, these are the state capitals, but now basically here's the size of, if it were exactly 10,000 living in the state capital, it would be this size, 100,000 would be this size, and 1 million would be this size. But if the state capital population was 200,000, it would be approximately twice as big as this circle here. So we can see that we basically don't just have 3 sizes of circles on this map, we're customizing the size of each one of those circles by multiplying it by the size closest to it and kind of getting a relative size of a circle on that map there. So these proportional symbols, as they're called, are a great way to make an unclassified map if we don't want to break it into categories or classes. Another way that we can do that is by making something called a dot density map. And with this dot density map, what we're basically doing is we're just putting random points within an area. So these points don't actually represent any particular places in Utah, they're just randomly distributed throughout Utah. But this might be something like the number of the area of farms or something like that within these different counties. So we can see the overall patterns here, but none of those individual points represent the actual instance of where something is. We're just seeing how dense those points are by putting more and more points into states that have more and more of those features such as farms in them. So in this way, this is also sort of an unclassified map because we're seeing the density, but we're not changing it by categories. We're just putting in another point whenever another 100,000 farms appears within one of these states.